Find the volume of the curve y equals x minus 1 quantity squared plus 2, shown to the right. Check. Revolved by the x-axis for 0 less than or equal to x less than or equal to 1. Okay. So it's nice, they gave us a little picture, so we got that going for us. And that looks like here we're going to use the disk method. So we're going to use the disk method going from left to right, from 0 to, looks like 1. So this will probably be 1. Okay. Yeah, okay, I'm good with this. Okay, so we'll do an integral of pi r squared delta x. And we'll go from 0 to 1. Now the question then is, what does this r equal? This r is the y value right here. So that's going to be x minus 1 squared plus 2. And so if we expand this out, we have r equals x squared minus 2x plus 1 plus 2, which equals x squared minus 2x plus 3. So now we're going to have to find out what r squared is. So r squared, change colors. R squared will be x squared minus 2x plus 3 quantity squared. Is there a way to simplify this? I don't think so. Okay. So we're going to basically multiply everything by everything else. So we're left with, I'll write this out first, so make it a little bit easier. So x squared minus 2x plus 3 times x squared minus 2x plus 3. This will be, we'll do x squared times x squared, which gives us x to the fourth, minus 2x cubed, plus 3x squared. Okay. We'll do the next section. Do a plus. We'll do minus 2x squared. Plus 4x. No, it's minus 2x cubed. Plus 4x squared. Minus 6x. Okay. And then we'll add the final group with the 3, which will be 3x squared minus 6x plus 9. Okay? That's a lot of work. More work than I intended. More work than I wanted. Okay, so start combining terms. We have x to the fourth. Yep, we have just one of those. Plus x cubed. We have a negative 2. Change colors so I can keep track of things. So we have a negative 2x cubed. We have another negative 2x cubed. And then we have, that's all. Okay? Plus, see, this is why I should keep one color. X squared, back to blue. Alright, so we have a 3x squared plus 4 plus another 3x squared plus x. So we have no x's in the first group. We have a minus 6x over here, another minus 6 over here, plus x to the 0, which should be just one value, which will be 9. Okay? Simplifying, which at this point it kind of feels anything we do would be simpler. Minus 4x plus, let's see, this is 3 6 is 10x squared plus minus 12x plus 9. Okay? And that we can do. I'm going to erase this abomination up here. Whoop. And now we're going to take this value right here, which is x squared. We're going to do an integral from 0 to 1. Move the pi out here. Move this up here. Get a pen. Click. Dx. So from a calculus point of view, this isn't too bad. But from an algebraic point of view, this is tedious. tedium. X to the 5th over 5. But at least it's to the 1st, so it should be straightforward once we get this done. Minus 12x squared over 2 plus 9x evaluated from 0 to 1. Okay? Do some quick canceling. So the 4's go away. This becomes 6. And we're left with pi times the quantity 1/5 minus 1 plus 10/3 minus 3 plus 9. Okay? So let's see, we'll combine some of the easy things together. So we have 1/5 plus 10/3, and then this is minus 4, so we plus 5. So it looks like we're going to go for 15 as the common denominator. So 3 plus 50 plus, ooh, what's 5 times 15? That's a lot. 75? 5 times 15, 5, 2, 5 times 75. Okay. Plus 75 all over 15 equals 103 over 15. That sounds odd. Let's check this out. Oh, 103. So this one looks closest. So maybe we're still on the right track. So let's see what we did here. Yep. Aha. I think this might be it right here. 6. So -1 minus 6. So this should be 2. Which would make this, what is it, 30? Aha. I see where we're going here. And so we're left with 83 over 15. Man, I'm surprised I was able to find that mistake. Good for me. Okay. Move this guy over here. Maybe not that much tilt. Just a little bit of tilt. Right there. Perfect. Get the right color. Blue. Circle. Proud of myself. Sense of accomplishment. Okay. So to backtrack, to look what we did, we had an equation. X minus 1 squared plus 2, which looked pretty simple. It's like, okay, not too bad. But the issue is that became our radius. And we have to find since we're doing the disk method, we have to find our radius squared. So we already have a binomial that we're going to square, then we're going to square that square, and it's just a lot of math. So, but we did it. We struggled on. We persevered. So we were already given a picture, so we kind of knew how to set things up. Go from 0 to 1, pi r squared dx, delta x, which the delta then became the d. We found our radius. We expanded that. Found our radius squared. Expanded that. Then I erased it because it bothered me greatly. Then we took that, plugged it in, and then it was just a whole bunch of the power rule, up and down. But all the power rule involved also was integrated from 0 to 1. So it kind of made things easier. We didn't have to worry about cubing x. Well, we did cube x, but it was either 0 cubed or 1 cubed, which simplifies life. Long story short, algebra. And following algebra, we found 103 over 15 pi, which was wrong. Went back, fixed my algebra, and I found 83 pi over 15, which is correct. Or at least an answer that's available to us. So that's how we do this problem. It was a lot of work, but conceptually, not too bad. We got this. Go team.